that's your presentation.
How long do you want?
Well, we usually want to allow good.
This one, yeah, I want to get it done in an hour.
Okay,
I'd like to get it done in an hour.
That'll give you a half an hour.
Not only Q&A, but discussion. I think this is the big
Right. So actually, Ted's going to read your bio and get his feet wet. He's new on our task force, so we volunteered him.
kind of like the way they volunteer me to speak.
Right. So he'll give you
No, they were out in front.
he'll give you a heads up when you're near that within that half an hour, that hour mark.
Yeah.
So let him know when
I don't know why I had a
2:30 is approaching.
I might even be earlier.
Yeah, but I think you're gonna have enough. Like I didn't think we're gonna have a lot of questions or anything so far.
This one's
And then we got a lot. So I think this one's probably gonna have a lot. So if we have a good half an hour or a little more, I think because that's going to generate a lot of discussion right there. So I think that'll be good.
I'll try and
What's happened
Yeah. That is the greatest ever. It is the most phenomenal adventure I have ever seen.
Quiet, please. Bueller. Okay, I've been asked to remind you. Questions? Write them down. Put them out in the hall. Fill out the form for the next conference. Be sure to do that. My name is Ted Lowry. I work for the state of Oklahoma. I'm going to introduce Ed Kabinski. We were wondering if we had a Fred in the audience to come up here and join us. We could have Ed, Ted, and Fred. Here's Ed's bio. Ed has been employed by Cromco LLC since August of 1993. His official title is Director of Regulatory Affairs, Training and Certification. He started his career with Cromco as a field technician and over time progressed to the foreman on the job sites for 8 years. Ed is responsible for understanding the regulations in all the states where Cromco conducts business, while also managing all licensing, training, and certification for Cromco's employees, roughly 140. On top of this, he oversees 6 other individuals that work directly with him in Cromco's compliance department. Ed is the chairman on PEI's RP 1200 committee. He holds numerous manufacturer and state certifications and is often found participating in regulatory meetings and industry work groups. He graduated from Bloomsburg University of Pennsylvania in 1993 with a bachelor's degree in education. Please help me welcome Ed to present our next session.
Thanks, everybody, for allowing me to come here and speak again. Went right from Bloomsburg into the tanks world. Didn't even bother using my education degree. But today we're going to talk about the new regulations and all this new equipment inspection and containment sump and spill bucket testing that's going on. And I'm going to focus obviously on how RP 1200 says to do this type of stuff. So the first thing we're going to cover is overfill equipment. As you guys know, there's 3 options for overfill equipment. For new sites in the non-SPA states, only 2 options, but for the majority of the states that have SPA, you're still allowed to install ball floats, vent valves or flow restrictors. Flapper valves is the second option for overfill, also known as overfill drop tubes, an automatic shutoff device. And your third option is a high-level alarm, typically attached to the tank gauge. So you can see here the ball float valves or vent restrictors are installed in the stage 1 vaporizer that attaches to the tank vent to prevent the venting once the tank gets near full. The flapper valves are installed in the fill, and your automatic tank gear or your high-level alarms are connected to the tank gauge. Just a slide from the recent NUIPIC webinar. So RP 1200, Chapter 7, goes through how to inspect and verify the overfill equipment. I'm gonna read on a couple slides. I'm gonna read through the wording in this section. Although the effectiveness of the overfill prevention devices can be tested by attempting to overfill an underground storage tank with product and determining how well the device functions, this approach is not recommended, obviously. Any malfunction of the overfill prevention device could result in a product release that could result in a threat to the public health and safety and environmental damage. So we don't want to overfill the tanks to check and make sure that our overfill equipment is working properly. Federal UST rules require that overfill prevention equipment automatically restrict flow or alert the transfer operator when the tank is no more than 90% full, or shut off flow into a tank when it's no more than 95% full. There are other alternatives, and many of the state rules have these alternatives in your rules. So other alternatives to prevent overfills are restricting the flow delivery 30 minutes prior to overfilling. Typically that's with a 30-minute ball float. Alerting the operator 1 minute before overfilling may occur, or automatically shutting off flow into the tank so that none of the fittings located on top of the tank are exposed to product due to overfilling. Now the committee understands that these were written into regulations, but when we were developing the standard, trying to figure out how we determine a delivery will stop 30 minutes prior to overfilling, or alerting the transfer operator 1 minute before overfilling, or automatically shutting off flow so that none of the tank fittings are located at the top of the tank, that was very difficult to do. So the committee, we wrote the practice for automatic shutoff devices to reflect the devices must be set to shut off flow when the tank is no more than 95% full, and flow restriction or overfill alarm devices must automatically restrict flow or alert the operator when the tank is no more than 90% full. We felt this was a little bit more conservative approach when writing the standard, and it would be not simple, but achievable when doing this work in the field. So here's all of our different options for overfill. So the first thing we'll talk about is the flapper valve, or the automatic shutoff device. So in RP 1200, we say to remove and inspect for damage, make sure that the floats move freely, latch mechanisms work, any bypass valves, if they're in the device, are open, and verify 95% level shutoff. And we do that by using the tank chart, looking up where 95% occurs, and then determining where on the drop tube shutoff happens, and making sure that that is at 95% or lower. So this just came from the webinar 2 weeks ago. OPW did a presentation on the webinar, and they gave a slide on their 71SO, which is probably the most common flapper valve seen out there. And you can see the flapper shuts off flow when it is horizontal and right at the top of the valve body. So when we're removing the overfill device, the flapper valves like 71SO, we're measuring to make sure that that top half of the top of the valve body is set no more higher than 95% in the tank. Just one other thing, this the RP1200, while it is a standard, this doesn't trump any manufacturer's instructions or manufacturer's recommendations on how they should do their equipment. So if a manufacturer does have a procedure for doing it, that can be employed to verify the overfill as well. The recommended practice is just a general guideline of how to do it. So some of the problems that we see with flapper valves, we've all seen the sticks in the tank, bypassing the flapper valves, broken flappers. I think that one on the right-hand side there came from Ben Thomas. They actually tack screwed the valve down, or the flapper down, so it wouldn't work. I just went out and we had a new crew of employees. We had 6 employees that just started last week, and one of the things we do with new employees, we take them out to a job site and show them the ropes, point out all the equipment, and our technician, our foreman there that you see in the picture, pulled out the overfill valve, and look what's missing, the flapper. So problem right there. According to RP1200, the pass-fail criteria for the automatic shutoff device, if the automatic shutoff device functions as designed, you look in the tube, make sure the flapper closes. Product flow is able to occur when the tank is no more than 25% full. The automatic shutoff device passes the inspection. If it doesn't function as designed and it's set any higher than 95% tank capacity, it fails the inspection. So moving on to the ball float. In RP1200, we say you must remove the ball float and inspect it. You need to check the ball, make sure there's no holes or cracks in the ball, check for the vent hole, check for 90% level, checking it against the tank gauge or the tank chart, visually verifying that tank top fittings are vapor tight. In order for a ball float to function properly, the tank top has to be vapor tight. If it's not, the ball float will not work. It's basically bypassed. And being consistent with RP100, the installation document for PEI, the RP1200 committee also recommends the removal of ball floats. So some problems that we see: broken cages. We were just out in North Carolina a couple weeks ago and pulled out a ball float, and the bleed hole was completely corroded through, so we punched a hole back through there so that it worked. If you have remote fill piping, you need to have a trap door assembly to prevent the cap from being blown off in the event a ball float checks up and the fill is occurring, so it doesn't blow the cap off. So pass-fail criteria for the ball float inspection. Ball float passes the inspection if the ball float valve functions as designed. Flow restriction occurs when the tank is no more than 90% full and the tank top fittings are vapor tight. If any of the following conditions exist, the overfill prevention fails. The overfill prevention system fails the inspection. So ball float valves are installed in a storage tank that is equipped with suction pumps and air eliminators. As you guys should know, that's an incompatible system design with a ball float for overfill. If the ball is cracked or damaged. One thing that we added in the 2017 version of RP1200 is if the ball float cannot be removed, it's going to fail the inspection. The committee felt strongly that it's very important that the ball floats come out. You can't just put a flashlight down there and see that it's. You might be able to see that it's there, but you can't necessarily make sure that it is functioning properly. So we felt it was important that this bullet point be put in there, that the ball floats need to come out to be visually inspected. The orifice is not at the top of the assembly, or it's clogged with debris or corroded, which we saw just a couple weeks ago. If ball floats are installed with coaxial stage 1 vapor recovery, ball float does not work with stage 1, coaxial stage 1, because the ball float is bypassed. Ball float valves are used on tanks equipped with remote fill pipes and gauge openings without the use of the trapdoor device that you saw on the slide previously. Ball float valves are installed in storage tank systems that are also equipped with an automatic shutoff, a flapper valve, and the ball float valve is set to restrict flow before the tank is 95% full. If the ball float valve does not function as designed, flow restriction doesn't occur, or it occurs at higher level than 90%, or the tank top fittings aren't vapor tight, or then the ball float valve fails the inspection. One note that, again, the committee felt pretty important to be in there, when permanently removing the ball float assembly, ensure the entire assembly is removed so as not to interfere with other methods of overfill protection. What we have seen in the past is, contractors want to get rid of the ball float, so they'll just take a stick and they'll pop the ball into the tank. Unfortunately, that leaves that riser, that little riser there sitting in the tank. And if you have a 90% ball float and the 95% flapper valve, once the tank hits 90% full, the flapper valve doesn't engage, your fuel is going to be going up into your vent line through the ball float assembly there if the ball is just knocked out. So, when contractors are removing it, you should make sure that they're removing the entire assembly. All right, moving on to the overfill prevention, the high-level alarms. In RP 1200, we say compare the ATG fuel level to the stick level. So you're going to pull out the probe, stick the tank where the probe is, and compare the levels. Check that the overfill alarm is on the tank gauge. We're going to actually activate the overfill alarm by removing the ATG probe, sliding the float up to activate the alarm, and we're going to make sure that that float height is at 90%. The pass-fail criteria, pretty simple. If the overfill alarm activates when the tank is no more than 90% full, the overfill alarm passes the test. If the fuel level on the console doesn't agree with the gauge stick reading, system fails the test. If the overfill alarm does not activate in test mode, it fails the test. If the overfill alarm doesn't activate, or it activates at above 90% tank capacity, it fails the test. It's pretty cut and dry. There are sample forms for documenting your overfill inspections in RP 1200. You could also look at some states, such as North Carolina, has developed a form for inspecting and testing these overfill devices. So if your state is looking for some forms for documenting it, there's 2 sources right there. And I'm going to hold the questions and comments until the end. So we're going to move on to Chapter 6 in RP 1200, and that covers spill bucket testing and containment sump testing. So for spill bucket testing, according to the EPA regs, first routine test is not yet required in most states, because most states have, SPA, and they don't have spill bucket testing in their regs yet. So, but for the non-SPA states, spill bucket testing is going to be required by 10/13 of 2018. Spill bucket testing is already required in a few states: Maryland, Delaware, Alabama. I think California. I'm not a West Coast guy, but South Carolina, their new rules go into effect in 2 days, and they gave 3 years for owner-operators to do their first round of spill bucket testing. North Carolina, first test has to be done for existing sites by 10/13 of 2018, so it's a little bit quicker in North Carolina. And Missouri also has it in their regs now by January 1st, 2020. First round of testing needs to be done. So when the regs go into effect, You could test according to manufacturer's guidelines. Again, RP 1200 provides step-by-step procedures, or if the state develops a standard of their own, you'd follow that. So for spill bucket testing, the majority of the sites have single-wall spill buckets. They're going to need to be tested according to the regs at installation, and then at least every 3 years after that. Some states are more stringent, such as Maryland. Spill bucket testing is an annual requirement in Maryland. Double wall spill buckets that are routinely monitored do not need to be tested. Again, except in Maryland. In Maryland, we would still need to test the interstitial space of the spill bucket. With the new federal regulations, they did say that if the owner has a double wall spill bucket and they're monitoring that interstitial space at least once a month and documenting that they're inspecting that interstitial space, that bucket would not need to be tested on a 3-year basis. According to the feds, testing is also not required for stage 1 vapor recovery spill buckets. However, other states disagree with that, and there's some states that require the testing of the stage 1 buckets, such as Maryland. So I'm going to go over the two different procedures that are in RP 1200. You can vacuum test and you can hydrostatically test these spill buckets. Option is up to the owner. We usually have a conversation with the owner and see what they prefer, and we go with that. So I'll cover both the different type of tests. The first test is the hydrostatic test. In RP 1200, we say you're going to clean, inspect, and repair any defects on the spill bucket prior to testing. Make sure the fill adapter and the cap are sealed tightly, or you can choose to remove the cap, remove the adapter, remove the drop tube, and you could seal below the drain plug where the bucket drains into the tank and test it that way using a plumber's plug. You want to make sure the drain valve is leak tight if it's going to be part of the test or it's permanently removed. You're going to fill the bucket up to within 1.5 inches of the top. We're going to measure the water to within 1/16 of an inch. We're going to wait 1 hour, and the water level has to drop less than 1/8 of an inch in order for it to pass the test. So when we're doing the test, or we're going out to do the test, we want to make a real good visual inspection of the bucket before doing the test, and we don't necessarily want to put water or make any more contamination if we see some gaping holes in the buckets. So we want to take a good look at a visual inspection before we test. There's some spill buckets that are going to be rather difficult to visually inspect. Again, filling the bucket to within 1.5 inches of the top. RP 1200 does give a sample document that you can use to document your test. So now moving on to the vacuum test. If we're going to vacuum test the bucket, again, we're going to clean, inspect, and repair any defects. We're going to want to make sure that the fill adapter, the cap, and everything's tight. The drain valve is isolated or it's permanently removed. We're going to seal the test cover to the top of the spill bucket. For that, we typically use a plexiglass plate with some fittings on it that you'll see, and a gasket underneath that goes on the plow ring of the spill bucket. We're going to apply vacuum using a small venturi of 30 inches of water column. You hold for 1 minute, and if the ending vacuum is 26 inches of water column or greater, the test is considered a pass. So here's some pictures of the spill bucket tester, the plexiglass plate and the small venturi. 30 inches of water column. So what about double wall buckets? Do we need to test, or is a test of the primary going to be acceptable? This is something that, some things that you want to consider as you guys are, writing in the midst of, rewriting your rules and providing guidance to the guys doing testing and the tank owners that are out there. So would a test of the primary bucket in a double wall spill bucket be considered acceptable? We've gone through this in the state of Maryland, and the answer is no. So we must vac test double wall spill buckets in Maryland. So do you even have to test the interstitial? Like I said, Maryland says yes, something that you want to consider when you're providing guidance to the people that are doing this work, because these are questions that are definitely going to come up. So if the spill bucket is double wall, it's monitored monthly, no test according to the new federal regulations. Florida, you still need to test every 3 years. Maryland, it's still an annual test. How's your state going to go with that? Actually, in a couple states, the double wall spill buckets, if there's sensors like you see here, or if there's a gauge in the spill bucket, there's a few states, Florida and Delaware, are making the testers take these gauges out and confirm that they're operable. So these gauges need to come out. We have to dunk it in water and make sure that the gauge moves properly. If the sensor's hooked up to a tank gauge, it's just like doing the monitor certification and testing that sensor to make sure that it's operable as well. So for testing the outer wall of a bucket, 1200 has a protocol for that. Again, clean, inspect, repair. Attach the vacuum source to the secondary access point. You're only going to apply 15 inches of water column vacuum. We're going to hold for 1 minute, and if the ending vacuum is 12 inches of water column or greater, the spill bucket interstitial passes the test. So again, what about stage 1 vapor recovery buckets? EPA says no, Maryland says yes. Think about the guidance that you're going to provide. What about testing spill buckets in a contained sump? Another question that comes up. So we're going to move on to the big elephant in the room, containment sump testing. According to the new federal regulations, if interstitial monitoring is used for release detection on double wall piping, you're going to need to test your single wall tank sumps and dispenser sumps for tightness at installation and every 3 years thereafter. You're using that containment sump under the dispenser and back at the tank to contain a release. You need to make sure that it's liquid tight. Double wall sumps that are monitored monthly with documentation according to the federal regulations, just like spill buckets, don't need to be periodically tested. As long as the owner is checking his sumps monthly and making sure that the interstitial space is in working condition and in normal condition. One thing to think about, has your state required interstitial monitoring when piping is installed after a certain date? So if so, the owners really don't have a choice. They're going to have to test their sumps. If testing, you can follow manufacturer's guidelines, RP 1200, or if the state develops a standard, follow that as well. According to RP 1200, here's what we say to do. Just like your spill bucket, you're going to clean, inspect, and repair any defects in the sumps. You're going to fill the sump to 4 inches above the highest penetration or sidewall seam in the sump. Measure the water to a 1/16 of an inch, wait 1 hour, and the water level has to drop less than 1/8 of an inch for the containment sump to pass. Again, clean, inspect prior to testing. We do see boots that go bad, so those would need to be fixed prior to doing testing. You don't want to flood the entire system from the dispenser sump down to the tank sump and put water in your piping interstitial. So you want to seal off the sump from the secondary piping. So these are small things we see in the sumps. So you fill the sumps up 4 inches above the penetrations. Again, 1200 has test documentation in the back of the document that you can use. So what about testing sumps that contain spill buckets or no pipe? Is your state going to require all sumps to be tested, not just sumps used for release detection? According to EPA, no, it's only the sumps that are being used for release detection. State of Massachusetts, state of Maryland said test all sumps, make sure they're all liquid tight. So again, it's one more thing to consider as you're writing your rules. Are all the sumps going to need to be tested? So as you guys know, and as everybody knows, and it's been a lot of talk about this lately, PMAA put out a regulatory report providing an alternative method for testing sumps, low-level testing. There were a lot of comments submitted to the RP 1200 committee regarding low-level testing, including myself. That was something I felt we needed to discuss. We discussed it several hours in the first go-around of the developing of the document, and we went around and round again, and we basically, reaffirmed what we thought. And as an industry best practice, we felt testing 4 inches above the penetrations and sidewall seams was the best way to go. However, there are some states that are considering the low-level testing. I think Colorado, I saw that in the Lustline article, that you could do some low-level testing there. Massachusetts put it in their regulations. We'll get into that in a minute. So here's just thinking about that, here's a picture that was emailed to me a couple days ago, a sump sensor program with positive shutdown, and that's the position it was in. So EPA clarified PMAA's request. Water can be reused for spill bucket testing. We're going to get that, or for sump and spill bucket testing. We're going to get into that this afternoon. I would strongly suggest that you not just read the PMAA document here. Go to EPA's website and look at their clarification on their frequently asked questions on this low-level testing. So I had mentioned Massachusetts put it in their regulations. In 2015, they gave all owners 2 years to comply to test all their sumps. And they said test all sumps, and if you have a sensor, you only have to test to the level that the sensor activates. Sumps that don't have a sensor had to be hydrostatically tested to the top of the sump. Standard for declaring a failure was the same as RP 1200, was an 1/8 of an inch or greater loss. So I ran the numbers, and I presented this data several months ago at one of Marshall Mott Smith's conferences. And I ran the numbers for the sump testing that we did in 2016 in Massachusetts. We did very little in 2015 because owners were, kind of waiting until the last minute. And this is what we saw. The majority of dispenser sumps are your high-density polyethylene, your plastic sumps. And we saw almost a 93% passing rate on the dispenser sumps. Fiberglass tank top sumps, almost 99% passing rate, and your polyethylene tank sumps, we saw about a 94% passing rate. And this is the first go-around of containment testing in Massachusetts. Those are pretty good numbers. In comparison, I'm going to share with you, a lot of you have seen this data before. I've done it at the Tanks Conference. I've done it at a few other conferences. We've tracked our data for testing in Maryland when Maryland's regs first came out. The RP 1200 protocol for containment sump testing was basically copied right from Maryland. We felt it was the best practice. A lot of regulations say containment sumps have to be liquid tight on the bottom, penetrations on all sides. So we felt, that what we put out there was the industry best practice. So what our Maryland data for fiberglass tank top sumps, as you can see, just between 50 and 60% passing rate on the first go around. And then over time, as you see, the testing got better. But it was rather painful in the beginning. For your plastic tank top sumps, they didn't fare quite as well as the fiberglass sumps. Just above a 40% passing rate in the beginning, but again, things got better over time, and we're seeing around a 90% passing rate right now. Dispenser sumps, again, started just under 50% passing in the beginning, and fare pretty well, 90. It looks like we're having a little tail off the last couple years. I wanted to leave plenty of time at the end of the presentation to talk about this, because I figured there's going to be a lot of questions, a lot of concerns, with all this testing and inspections that are going to go on. I had a question for the audience. With all the states being here, are any other states considering the low-level containment testing? Several of them. Any reason why? Would someone care to share? Why?
So my shop's living from Colorado.
Yes.
So I kind of wrote that article in last line, and kind of one of our reasons behind it was the water disposal quantity issue. But also we do periodic inspections, and so as you pointed out, there could be an operator that has a sensor sitting on the top, but that's not how it's supposed to be. So, hopefully through our own inspections, we ensure it's placed properly. But that was one of the primary drivers on that. I was also concerned a little. It's a good option. It's not a great option, because if you have sensors in the dispensers, you're shutting all products down, essentially, too. Or if there's connectivity between the secondary piping. So somebody may choose to do that. We've seen that done on some above-ground tank systems. We've had that in place prior to this, and we've allowed that as an option. So that seems to have worked out there. I do have a question for you on RP 1200, since I have the mic here.
Sure.
My concern is the first step, which is clean, inspect and repair. And really, I'm getting hung up more on the repair portion, because it gives you a false sense of how much of a repair can you do, and then is that really a fail? And I guess my concern is because we deal with the cleanup, the environmental aspect of if it was leaking, is there contamination in the environment that needs to be cleaned up? And there's a false sense of, hey, we got all this great passing rate, but really it wouldn't pass if you tested it in the as-found condition, right?
Right.
What's that?
Yeah, I mean, as a tester, we'd be able to make more money, and with low-level testing, we'd be able to get in and out quicker. Water disposal is obviously a major issue, and we're going to talk about that a little bit later today. But yeah, I should. When we talk about repairs, prior to testing, I don't know about any other contractors that do containment testing, but our guys that are doing this containment test, this hydrostatic testing day in, day out, they're not equipped to make substantial repairs in the sump. They're not equipped to put new boots on. It's small things. It's tightening a hose clamp and making small repairs that they can do prior to doing a test. You want to visually inspect it. You're not going to test it if the boot's torn and there's absolutely no way that you're going to be able to test. So they occasionally need to tighten a few things up. Maybe an electrical conduit fitting that was open. They need to put the plug back in or something like that. So minor repairs are done prior to testing. Nothing substantial.
Is that spelled out? Like, what's the scope of the repair?
In RP 1200? No, it's just repair what you can. You know, there may be other contractors that send, you know, repair. We have repair specialists, but they're going out and doing repairs every day. They're not going out and doing the testing. They're following the testers up and making the repairs, because it's a, you know, it's definitely a different animal, you know, doing the containment sump repairs. And not every one of our guys are trained and, you know, certified and capable of doing it. It takes it's a specialty service. But,
Yeah, I'm just messing with him.
Just to confirm, Massachusetts is allowing low level without positive shutdown, as long as it has a sensor. Is that correct?
that's correct. And yeah, correct me if I'm wrong, but yeah, Massachusetts does not require positive shutdown with the sensors to do the test, and that's right in their regulations. I'm sorry? Massachusetts does have SPA. So the Massachusetts regs are, you know, in effect, and that's what we follow until they redo their regulations. One thing I did want to mention, I've been on, you know, numerous calls with PEI and a couple of the committee members regarding, you know, that letter that went out, and obviously we want to address that. And PEI has set up a webinar that we're going to do to further discuss it, since, you know, this just came out and it's, you know, kind of hitting everybody, you know, from all sides, getting questions and emails, you know, all the time about this. So mark your calendars, July 12th, PEI is going to have a webinar, 11 o'clock Eastern Standard Time, on this subject, and we're going to be discussing it further. We're going to have some of the several members of the committee on this call. I don't know what the agenda is going to be. We're going to discuss it more, and maybe hopefully you'll be able to ask questions. But
Yeah, Dave from Delaware. Just a question, if you have any data on like an average lifetime of a spill bucket, how long they're good for. I know it's going to depend on the area and freezing of water.
yeah, that's a good question. I don't have any data. I don't have any data that would back this up. I've heard it a number of times in the tank conferences, but I've heard anywhere from typically from 5 to 7 years in that neighborhood. You know, maybe the newer buckets are, you know, even better. But that's typically what I've heard from manufacturers, about 5 to 7 years. Mark?
Yeah, sure. This is Mark. Probably fair if I speak to this a little bit. It kind of came out late last week, and I'm not sure even everybody has had a chance to see it yet. So I thought I should speak to it for a second. You had some fair questions about the why. So I want to make sure everyone knew how this played out. So we've been getting a lot of questions about alternatives, and the way EPA's regs are written, we say you can do something in accordance with the manufacturer's instructions, in accordance with code of practice, or an alternative approved by the implementing agency. And we have that in a lot of the different areas. Some of you guys probably do too. So the question was, for that third one, could there be an alternative? And we've been getting the question from states, we've been getting the question from the tank owning folks. And some discussions we had with the tank owning folks led to some other issues and questions that came up, and this was sort of feeding into the why we sort of started having these discussions. And one of them is that for a lot of especially the older systems, the secondarily contained systems, that in order to do the testing above the penetrations would require working on all the seals for those penetrations, because otherwise initially at least they wouldn't pass. And that meant, especially in the older systems without much access, that meant removing the dispensers. So it means taking off the dispensers every time this is going to happen, especially for some of those older systems. The other kind of questions that came in were, well, if we voluntarily put in a secondarily contained system before the state, well, all you guys were ahead of us in terms of secondary containment. So before the state regulations for secondary containment interstitial monitoring came in, can we just stop using interstitial monitoring and do leak detection as if it were a single wall tank? And according to federal regulations, yeah, you can. And so the sense was that would be the direction that a lot of folks would go. Again, those who didn't have to do interstitial monitoring because of the date of their installation. And we looked into it, talked to a lot of folks, and so when we had a Q&A that if you folks haven't seen, it is up on our website, and what we say is, at present, the code of practice is to test it 4 inches above the penetration fittings, which, which is what we've been talking about. So, just testing to the lower level would not be considered as stringent. So that in and of itself, from EPA's perspective, would not be considered as stringent. However, in the sort of that third area where you can have sort of an alternative determined that's as basically as stringent, if you package that with an automatic shutoff, then that combination, while not as good in some ways but better in other ways, that combination we EPA would consider to be acceptable. Then it got a little bit more nuanced because, well, what kind of shutoff are we talking about? And if it's the shutoff of the of the STP, then fine, it's going to shut off. If it's an automatic shutoff of the dispenser, then there's going to be a continued pumping of that fuel, and so that was then coupled with only if it's at a tank that's currently sort of, there are people there operating it. I forget the language we used on that, but so that someone can notice the dispenser shutting down and respond to that in a reasonable amount of time. So I just want to give that, for those who hadn't seen the Q&A, that's a little bit more of the discussion that's in the Q&A, some of the rationale behind it, and some of the explanation that it wasn't just low-level testing, it was low-level testing in combination with something else, and sort of the in combination with something else. And you all may have other scenarios or packages or combinations of things that you all determine are no less stringent. So I just want to make sure it's not fair to have Ed have to describe and explain everything that we just put together and came out a couple days ago. So I just want to make sure I did that explanation.
No, that's all right. And it's not like the RP 1200 committee totally doesn't agree with that. We felt, again, this is a recommended practice, and it's what we felt was the best for industry. And if you're going to do that, we felt, and you're going to be relying on the containment sumps to contain a release, we felt that the sumps, that would be the best way to test the sumps. And then we also felt that if a state wants to allow low-level testing, such as Massachusetts, Colorado, have at it. Go ahead. If that's what you want to do and you're comfortable with it, we're more than happy to do testing that way. It makes our life easier as well. It's, we can get in and out of sites quicker. But that's why we felt we spoke with a number of state regulators, and we said, well, what if Mike from Maryland is on our committee, and we put it right on Mike, and we said, Mike, what would you do if the 1200 committee changed the standard to low-level testing? He said Maryland would not accept that, and they would go right back to the 4 inches above the highest penetration or sidewall seen. And a number of states said that because they feel that that's the right way to test the sumps. And again, like I said, in some of the regulations, it does say sumps need to be liquid tight on the bottom penetrations and all the sides. So that's why we decided to stay with what we had. We felt it was the most protective of the environment. And if a state chooses to go low-level testing, and they go through the SPA process and get it approved, we'll comply with that as well, and we'll do the testing in that fashion.
One, I guess, comment for Mark more than anything, not really a question, is I think a lot of states are at the point, too, in the rulemaking process. And again, with Minnesota, we're close to the public comment period, and we have been getting quite a bit of pressure from PMA. This just opens the door now, because I don't think we're proposing accepting it, especially if it's not in recommended practices. But now the chances of having to go through a public hearing, I think, just jumped quite a bit. So that's a little concerning with the timing of it. It kind of puts, I think, states in a sticky wicket there. So.
Yeah, the committee overwhelmingly, agreed that that we did not want to change the standard.
Ed, I had another question on the for double wall containment and monitoring that so that it's exempt from the 3-year. You're required to do like a periodic or a monthly inspection of the double walled, right? So is that what's that inspection?
It would be just like doing interstitial monitoring on your tanks or your piping, but to my knowledge, I don't have much experience with double wall sumps, but what we saw in the previous presentation, you typically have a brine reservoir, so you would have to document that the brine is in the normal operating condition, or if it's under vacuum, document the vacuum level that the interstitial space is at.
Sure.
Once a month. It's just like doing release detection. That would get the owner out of containment testing.
So on the brine, it's pretty straightforward. You'd kind of document the brine level. On a vacuum, you're dependent on first having a vacuum gauge there to make sure you can read whether it's under vacuum, and then account for the deterioration too, right, of the vacuum
I guess
over
so.
time.
I don't have any experience with it,
Okay.
so I don't know that I'm the right person to comment on it.
Okay.
But and I don't know what the vacuum level they pull on the double wall sumps. But you would need to monitor. If it's a double wall sump and you want to get out of the testing, you would need to be monitoring it at least monthly according to the EPA regulations and documenting.
And documenting.
Yes, and documenting that. You can't just say I'm doing it.
Sure, yeah.
You don't let owners get away with that for release detection, right?
Yeah.
I'm doing it.
Yeah, Ed, Tom Walter with Maryland. Okay. I just want to share some experiences that we've dealt with in Maryland when we implemented the sump and spill bucket testing in 2005. And your slide is right on that it is painful at the beginning. What we experienced a lot was a lot of the sumps did not have entry fittings or did not have test boots on the entry fitting. Tank owners, as they became aware that they had to test these sumps, they were paying contractors to come out, and some of it was jury-rig type of repairs. They were just putting caulking on it, on crack spill or entry fittings, just whatever they could do to make that sump pass. And when you see the numbers go up and down, in many cases that was our second round of testing on a containment sump, and the first round, whatever type of repair they perform was failing. We would not allow them to repair using any type of caulking or Bostik material. They actually had to install new entry fittings on their containment sumps. It was painful, but I can tell you it was a savior for us on a lot of the small spills that we were missing. To this day, we find a lot of product in containment sumps during our routine inspections. Even with the spill buckets, today we find spill buckets. We're on an annual basis for testing spill buckets, and we're finding spill buckets that when they come out, they're cracked or they're leaking.
Yeah, I would definitely put some guidance out to your contractors in your states on what you would expect for repairs, because like Tom said, there were pretty, in the beginning, there weren't really repair options, so people were just doing whatever they thought to be able to seal up the leak so that they could get a passing test. And they were schmutzing and Bostik, and it was kind of ugly in the beginning. But now there's definitely there's a handful of different repair options out there. You got Bravo, you got Diversified Products Manufacturing, and you got Icon. They all have repair options available for sumps.
I have two questions, one for you and one for the states. In RP 1200, it lists the compatibility issues with flappers and ball floats only in the ball float section, but not in the flapper section. So I guess my question is, it seems like they should, if they're checking flappers, or there are flappers, they should be verifying then that ball floats are not installed also as part of that testing criteria?
That I believe that is in 1200. I'm going to have to pull it out and double check, but I believe, if you're doing the flapper valve inspection, you also need to ensure that there's not a ball float that's going to interfere with the flapper.
Okay.
I believe that's in the document.
In the new one? I don't think it was in the old one. but I'll have to double check too. And then the second question is for the states. OPW's got the testable drop tube. As you pointed out, it's easy to have there not be the float on the flapper, and their testable drop tube just pulls on that metal portion. And I'm wondering if any states will not be allowing testing of using that testable drop tube.
I'll comment first, and then you guys can discuss. But again, the 1200 committee felt that it was important to exercise the drop tube at least once every 3 years and remove it and do a good visual inspection on it. That's why we say remove it. Now, the 1200 document does not trump any manufacturer's guidelines or requirements. So if the manufacturer says it's testable from grade and this is how you do it, I guess that I would have to leave that in the state's hands to decide if they're going to allow and accept that. And it's not only OPW, but Franklin Fueling has a testable from grade overfill prevention valve as well. So does any states want to comment on whether or not they would allow the flapper valve inspection to be performed without removing the?
We are in Delaware. We're allowing it, and part of the reason is because of our decommissioned, our stage 2 decommissioned sites. If they have to pull the drop tube, then they have to have somebody that's certified to work on that system do it, and then make sure it's tight again. So yes, we are. So are you requiring in Delaware that another vapor recovery test would have to be done to verify that the tanks are vapor tight if you take apart the system at all? Yes, and anytime any work's done that makes the system not tight, they're required to do a pressure decay.
Okay. Makes sense.
In Maine, we require them to be taken out all the time, and that's on an annual basis, not on a 3-year basis. In an annual inspection, they have to pull them, and commonly, if it's been 2 years, it's hard to pull them. So,
I agree with you. I've broken many a drop tube in my days.
I'm with MCO Wheaton, of course. We're a manufacturer of overfill prevention valves. We have not made a testable from grade overfill valve yet, but we will have one because we're falling in line with the others. But we still, in our practices, we tell them that you need to remove it once a year, because if you go out there, even after 18 months, especially in sites like Florida, they can't get those out. There's so much corrosion, and if that flapper valve gets stuck open, so we're still at the position where we're going to add it to our overfill prevention valve, but we're still going to require it to be taken out once a year to be visually inspected.
In Kansas, we did not approve the OPW, but we did approve the Franklin. So, if that helps.
Why was that? Why not the OPW?
We didn't like the testable mechanism for the OPW.
Fair enough.
In Connecticut, and this is along the same lines of overfill, but not specifically related to the flapper valve, I'm one of the 5-member team that is rewriting the regs in Connecticut, and we just wrote into our regs that we are no longer allowing ball valves as overfill. We're just not allowing it for new installs, and we're considering putting a deadline date for them to be changed over to either audible or visual or flapper valve. And I want to know if there are any other states that's considering it or have already wrote that into their regs that they're eliminating the option as a ball flow, because we see balls floating around, the baskets are all rusted out, the balls are floating in the fuel, and it's just not an acceptable overfill method for us any longer. Is there any other states that's been considering that?
Going to have to deal with the owners on that, because there's going to be some expense to. You're going to have to excavate occasionally to get those out.
In Missouri, we were with Kansas, Marcus. We did the same thing where we approved the Franklin fueling self-testing device, but we did not approve the OPW one at first. What I will tell you is that they have done some additional testing after a very lengthy debate with them, and one of the things that they did is they were trying to demonstrate regular wear and tear, where would their flapper valve fail. So they put a bunch of weights on the bottom part of the float and basically put weights on it until it gave, and the float portion never separated from the metal portion. So the discussion that we had with them was normal wear and tear, the self-testing system would probably catch all of those issues. So then the debate came down to what is more tamper-proof. And I will tell you, as a state, that got us into a little bit of trouble because everything can be tampered with in some form or fashion. Pretty much everything can be manipulated, even the Franklin fueling one, which is supposed to be tamper-proof. We had it for a day and figured out numerous ways to tamper with it so that it would pass the self-testing. So after we did that, and we did the same thing Marcus did, we went further into it, and we've now approved OPWs as well. Universal also has a self-testing one coming out, and I suspect we'll get similar questions and we'll ask for similar studies like that.
I guess the challenge that I have with the testable from grade is how do you determine that it's set at 95% or lower without removing and measuring?
They have, it's in their protocols how to do that. Both of them have that in their protocols now.
And if you have all the installation documents, with all the measurements, I could see it, but a lot of that stuff gets lost.
Still overfill. In this, we have for audible and visible alarm. We say audible and visible, but the EPA checklist we use says audible or visible. Sometimes we go to the field, it is either audible or visible. It's difficult to give an infraction for that, so we have been debating, to say it's audible and visible, to rely on what we have, not on what EPA has given us for the checklist. In addition to that, we are also contemplating to not use ball flute, for any new
installs.
Yeah, new plants, So that's why we are in DC.
Yeah, I just wanted to point out that the federal regulations for new installations, according to the federal regulation, after October 13th, 2015, they can't be installed. So we're expecting states coming in for reauthorization to follow that as well. Whatever that date, it's not going to be 2015, of course, but it's going to be for new installs. It sounds like, Omar, you are going beyond that, where you're saying any system, you're going to make sure that if a system has currently ball flutes, they can't use that. They'll have to take those out. That's beyond the federal requirement, and that's fine. But I just wanted to clarify that the requirement for new installs, or prohibition for new installs not to install ball flutes, that is already part of the federal regulations. So.
And Tim, correct me if I'm wrong.
Oh, wait a minute. Here.
Would you still be able to install a ball float if the owner wanted a secondary means of overfill? If they had a high-level alarm or a flapper valve as their primary overfill device, and that's the one they would be inspecting and testing, but they wanted a real short ball float, because I know some of our customers, they like the idea of a backup, and if I could go back to my one slide, you can see. Give me a. Whoa. Where our technician is there, you can see when this owner actually had short ball floats installed in the tanks as well for a backup. So even though the tank didn't have a functioning, flapper valve in the tank, they did have a secondary means just in case. So some owners like to have the belts and suspenders, backup.
Belts and suspenders are fine. Yes.
But it's got to be installed properly. It wouldn't be able
exactly. The 95 and the 90%, they can't be affected. So yeah.
Correct. Okay.
Ed, I've got a question and I guess a comment for regulators as well. Did you consider or discuss tolerances for making the measurements on the, particularly like a flapper valve? You know, if you've set these at 95%, and if a contractor went out and did 100 of them right at 95%, there's probably, you know, if you put a bell curve on it, probably about half of them are going to be an 1/8 inch too long and half about an 1/8 inch too short. You know, so what are the reasonable tolerances, if any? You know, if you get one that's like a 95.3%, or if it's at a 1/8 inch too short.
You know, it's got to be 95 or lower. You know, we've seen inconsistencies in measurements, you know, over the years. You know, I guess you know, to be safe, you know, install it a little lower.
And I guess just as comment, you know, if regulators are, you know, putting in rules, you know, that's something to consider. And for the manufacturers that might be here, perhaps the installation, or for contractors, you know, in order to pass these 3 years from now, you probably got to put them in at 94%.
To be safe.
Just a comment.
Any other questions? Yeah, okay.
Can Mark or Tim please clarify the EPA frequently asked questions that was put out last week regarding the low-level sump testing alternative? It states, and I'm doing this off the top of my head, that you need positive shutdown either to shut down the pump or the dispenser. Is that or intended for a sensor to shut down the pump if it's in the STP and the dispenser if the sensor is in the dispenser pan? Or can a sensor and an STP sump shut down the dispenser in lieu of the pump? Did that make sense? Okay, so if you have a sump sensor in an STP sump, can it shut down the dispenser only and achieve the low-level testing alternative?
I'll take the correct and definitely jump in, Mark. Correct me if I'm wrong. That option that we put out there, that was for states to consider. That was kind of like the minimum for what we would consider to meet that no less stringent. As the federal regulations are written, it clearly allows 3 options. The first option is the manufacturer's instruction. The second is the code of practice, which is RP 1200. And then what the states consider as no less stringent. There was a whole lot of questions on what do we mean by no less stringent? What does EPA accept as no less stringent? So we put that out there as an example. If you come to us when you're writing your regulations, for instance, this is no less stringent, before going back and forth having to go redo our regulations another 3 months, we want this to go the first time. Give us some ideas. That's what we provided. That's not really EPA is saying, yay, use this low-level, right. So we set that as a bar for negotiations or your consideration. But go ahead.
Yeah, so, but I think the question, though, is whether it's the dispenser sump or the STP sump,
yes,
we didn't sort of distinguish between which one would shut off the pump and which one would shut off the dispenser. The understanding is that there are certain facilities that are wired in a way that, at least from the dispenser, they can't get to do a shut off of the pump itself, and it only can shut off the dispenser. So in that case, as long as the facility is staffed when the pumps are operational, then that would be okay. But it wasn't dispenser shut off if it's in the dispenser sump, or pump shut off if it's in the STP. If that's what you were asking.
That's it. Yes.
So we're relying on, if it's a dispenser shut off, we're relying on the human to know how to get shut off.
Yeah, there's a connection. Right, the connection would be if the dispenser shuts off and it's an operating facility, there's someone there to react to it. Again, there are holes in every aspect of our regulations. There are holes in this alternative. There are holes in the other alternative, and having some sort of an automatic shutoff is an additional safety factor. And sometime in between that 3-year test, you actually have that option, so that's helpful. But yeah, there are on the flip side, there are downsides to that package. So it's not better in every way or worse in every way. It's better in some ways, worse in some ways. But the package is sort of overall comparable is what our sense was.
So I guess I have a question for the spa states. So if an owner wanted to proactively begin testing his sumps, and he wanted to follow this low-level testing protocol, since there is no, let's say, containment sump testing requirement in your state, and he went with the EPA, this EPA alternative, would that be considered a, acceptable test?
I get a comment from New Hampshire. We've always required an installation an inch from the top. And so if they did not do that test at this point, and if they went to positive shutdown, that wouldn't be acceptable.
Yeah, and I think it's pretty clear in your rules how sumps have to be tested.
Yeah.
You get hit with
In Colorado, we also have the same requirement that at installation and a year after, you have to do a liquid test. And so in combination with that, the positive shutdown to only the STB sump, we don't have the option of you can just shut your dispenser down. It has to be the one STP or all STPs.
Right, and I believe, we've had discussions that RP 1200 committee on that, and that's something that we definitely agree on, with the low-level testing.
Sure.
If you have a dispenser sensor that goes into alarm, it would have to shut off all the products associated with that dispenser.
Right. Yeah. Absolutely. And we think it's more protective because you could have issues in between that 3-year test.
So you do a test at installation, 1 year after installation,
right?
4 inches above the highest penetration, or what?
We say an inch above. So I think that's.
Okay.
Yeah,
so you do test the penetrations and sidewall seams at installation a year after, and then you can go to low level.
Right.
Did respect to ball float repairs, did RP 1200 get adjusted to that issue that I emailed you about?
Some code?
We did not. We do not suggest that you repair any ball floats. If we suggest removal of the ball floats if it's found defective. We can't. It's not a regulatory document. We can't require the removal. We would suggest removal, instead of repairing.
In Maine, to your question on
the sump
testing, if we haven't had a rule on it, we don't have the rule on sump testing requiring it yet. So a test would be considered a diagnostic test, and how they'd like to do it is how they'd like to do it, because we're not requiring the test. Now, that being said, if they find a fail because of it, then they would have to respond to it and notify us and repair it. But we don't have any specifications on how they do that testing.
And that's kind of what I figured in most spa states. If you don't already have testing guidance, or if you don't have it in your regulations, it's kind of do what you want.
I have a question for Mark or Tim. I know it probably sounds like splitting hairs, but when you're an island in the middle of the Pacific, every gallon counts. Would you likely consider it equally as stringent if we filled 1 inch above the penetrations instead of 4?
It can't be any less
less protective.
No, thanks. Yeah, actually, I'm not sure why it was 4 rather than 1. I honestly don't know. I would be open to that if there are no penetrations between the 1 and the 4. I don't know that that's a huge difference.
It's just a little bit of it's just a little bit of additional head pressure from the water on the fitting, but the difference of 1 and 3 inches or 1 and 4 inches is negligible.
Yeah,
and from our experience, when sumps fail, it's not you're looking, is that an eighth of an inch or is that a quarter of an inch? It's usually a fail is you know it pretty quickly.
Right. So I guess that's a fair question, and we could discuss it at the time. But that's probably the kind of thing that if a state decides that you're comfortable with that would be within the range. Yeah.
Question for you, Randy Martin from Pennsylvania. One is the new PEIRP 1200. Does it cover anything about the spill catchment basins, the concrete catchment basins instead of spill buckets? Testing those.
No, we did not mention anything about those.
We're wondering how they're going to test those.
So it's just a concrete block around the fill?
Well, there's a truck stop that we're dealing with where they basically have all their fills in a concrete box.
Okay.
Basically, and in the side of the box there's a notch which is connected to an oil water separator. So how does one test that?
We actually came out, the task force actually came out with a white paper regarding that.
Mm-hmm.
And in Wyoming, we came out with a guidance document that they considered those to be less protective of the environment than a spill bucket. So we were able to use that because the federal regulations say that it has to be tested in accordance, in lieu of a spill bucket, it's got to be no less protective of the environment than a spill bucket, right? Mm-hmm. Well, that white paper actually puts justification of why we feel it's less protective of the environment. So that's what we did for our justification. So that white paper is on the Ashwama website if you want to take a look at it.
So you basically eliminated that option, is what you're saying?
Right. In Wyoming, we just said you got to take them out.
Okay.
And add spill buckets. Exactly.
And 1,200 can't account for every situation that's out there. That's a pretty unique one.
Another situation, 2 more actually. Another situation that we ran across is facility owners, the same kind of deal, but they had portable spill buckets where they'd actually put a spill bucket on during their delivery and then take it off. So our new regs are saying permanently installed because of that. Another issue we came across is some of our facilities use whistle vents to fill tanks, which is a portable. So we're eliminating that. We changed our regs to say permanently installed to eliminate that. So that's just some things that we've learned in Pennsylvania and how we're eliminating them in Pennsylvania.
Pennsylvania's still looking at eliminating the 30-minute ball float option as well, correct?
It's strike from our draft regs right now. Yeah. The other thing, too, is obviously with all this testing, and we've had this discussion, you know this, as a little background, there was a bunch of steel tanks that were repaired in Pennsylvania, and I started asking the question, to what industry standard were they repaired? And of course the answer was none. So I got elected to be on the STI Steel Tank Repair Committee to deal with that. Now, one of the things that we're going to be seeing is a bunch of sump repairs that are going to need to be done. Not talking the penetration fittings, but cracks, holes, etc. There is a repair standard for fiberglass sumps out there, and LPA and KWA teamed up to do that one, and I was one of the ones who kind of pushed that one in the right direction. But we're going to see a bunch of plastic sumps that are failing. Does anybody allow currently plastic sumps to be repaired, and what industry standard?
Well, as you know, they're
like the environment.
Yeah.
For total containment.
Yep.
We've had some contractors.
Sure.
In New Mexico, we've had some of the contractors come in and propose, basically, I think I've heard other people talk about it, just they find the damage, just cut a hole, just cut it out and glue back over. And we've gone back and said, well, Environ, I mean, you look at it, we try to find as much of the old Environ literature as we can. We can't find anything that says that's an acceptable repair. And so basically, we just, the latest one where we went round and round with it, basically finally the owner said, I'll just put in a new sump. So, and one thing I want to address is New Mexico. Now, when they amended in 91, the overfill, added in the new overfill, the different alternatives for overfill, New Mexico never adopted that. So we have it where it's just 90 for the ball float, 95% for the flapper. And so we never, and one of the things we're looking at right now is on the ball floats, we have a lot of older facilities. They were in areas where there was never vapor recovery required, and they basically concreted over the ball float risers. And is that something in a lot of states that have rural and remote areas are going to, you think you guys are going to find?
If they can't be extracted in compliance, I mean, for annual inspection.
Okay.
And there was one other thing about the catchment basins you were talking about. There is no industry standard for testing those, and there's nothing by the manufacturer, so that's another reason why we didn't disallow them.
There was a suggestion to PEI to develop a standard for sump repairs, and committee chairs voted on that this year, and they voted that it should be made a document. So that's a possibility that might be coming out in the near future. Let's hope so. You're going to be on the committee, Randy.
I kind of have a change of subject real quick. For those states that are rewriting their rules right now to come into compliance with the federal regs, are you guys giving the 3-year implementation time frame for the sump testing and the other things, or are you considering reducing the time frame to like 1 year to match the 2018 federal requirement?
I can comment because I've worked with a few states on their rules, and I know like South Carolina went through their rule change, goes effective 5/26/17. They gave 3 years to do your first round of testing and inspections. North Carolina, we were out with them a couple weeks ago, and their implementation date is 10/13/18 for their first round of testing and inspections of existing facilities, so it's a little bit quicker. I know in talking with all the owners, they would like as much time as possible, especially the large owners. They have a lot of sites. They like to stagger. Their compliance over. If they have 3 years, they can do a third and a third and a third. It doesn't hit their budgets quite as hard, as it would if they only had 18 months to do all their facilities. So, there's going to be quite a bit of work involved with all the testing and inspections with these new regs. So, when you're writing these regs, give the, I'll talk for the owners a little bit. Give them some time, because it's going to be there's going to be a lot of repairs and a lot of work to be done.
So this is Liz McDermott from OUST. We have looked at 20 states so far, so here's a little plug for as you're doing your regs. Please, we're happy to help you. Your region can help you. We're helping to review the regs. We find something in all of them, so we'll give you some suggestions. We'll give you some, oh my goodness, if you come in with that, you're not going to get SPA. So just remember, as you're doing the process, we're happy to help. Of the 20 we've looked at, it really varies. There's some states that are keeping the federal deadlines, so it's going to be pretty quick for their owners. There are others that are doing 3 years from their effective date, and there's some in between. So whatever works best for you, whatever you can get through your state, it's perfectly acceptable. The most you can give them is the same amount of time that EPA gave them for that particular item. So testing 3 years from your effective date. But Mark wants to say something here too. So.
Is this on? Yeah. For states that don't have program approval currently, and there are 16 states and territories right now who don't have it, in that case, the federal deadline applies for the owners anyway. Mm-hmm. So that's relevant when you're thinking about the timing that you all are going to give. If it's a current state with program approval, the federal regulations simply don't apply right now. So, whatever time you give is the time you give. So, something else to keep in mind.
We've gone out and made sure that all of our owners know that this is in existence, and each with our inspection reports after we're done with our inspections, we let them know that those are coming down the line. So we didn't even bother putting a deadline in the rules because the rules are going to go into effect after the deadline anyway. So.
Maine's rules are still in draft, but one of the things that we're probably going to do with regard to implementing the 3-year testing thing is we're looking at, we looked at our tank population, and we may split it in half or possibly even in thirds for start dates based on installation dates of the facilities. And it's an easy thing to count and identify in our database. And again, I'm saying this kind of vaguely because I don't remember off the top of my head right now if we were going to start with one set right in 2018 or not. But whether we do or not, we're going to try to stagger it.
Guess that's it. Let's take a 30-minute break, come back at 3:30. Let's give a big round for it.